Good morning, students. Today we are going to discuss about the basic statistics which we can use in machine learning. Now, before studying about the formulas which is related to the statistics, first of all, we want to discuss that what exactly the statistics is. So, statistics is nothing but it's a branch of mathematics which deals with numbers and data. So as we studied in our childhood that whenever we are talking about statistics, a number and data will come into our mind. So what we are doing with the help of statistics, we are collecting the data, then we are analyzing the data and we are trying to interpret something from the data and we are presenting that into a different form and finally we are organizing the data. So statistics is a study of collection, analysis, interpretation, presentation and organization of the data. Fine. So we can say that with the help of statistics, we can deal with the facts, we can deal with the observation and information which can present in the numerical data. So the major concern here is we can statistics can be applied on the numerical data only, and with the help of statistics, we can able to find the various measures of central tendency, and we can find the deviation of different values from the mean, deviation of different values from the median. All these things we can find out with the help of statistics. So this is the basic what exactly the statistics is. So now we are going to discuss in this lecture the different statistics formula which generally we are using in most of the time in our maths as well as in machine learning in the same way. So what are the different formula which we are having here? We'll discuss about mean, we'll discuss about median, mode, variance, standard deviation one by one. So these are the formulas which are there for these uh, statistics measures. One by one, we'll discuss all these measures with the help of example. Now we'll start with the mean. So as you all know what is mean, mean is nothing but the another word of average. So average can we can say it's a mean only. Fine. So when I want to find the mean or average of anything, we all know that how to find average. Just will add all the values and divided by the total number of values. That will become mean. So these are how many values we are having here. Six values we are having, and the sum of all the six values is 72. The number of value is 6. So mean value will be 12. Now in the same way, I want to calculate median. So when I want to calculate the median for even numbers and the median for odd numbers, then it will be a little different. So when I'm saying median for odd numbers, so the middle value will become your median. So we have a value 1, 3, 3, 6, 7, 8, 9. So what is middle value for this? 6 is a middle number value. So 6 will become median for this data set. If values are even, so median cannot be found directly using this method. So what we have to do, we have to add the middle two values and divided by 2. So that will become median here. So how many values we are having here? 8 values we are having. So it is even values. So finding the median of even value, how we can find? We'll take the average of middle two values. That will become your median. Fine. So this is your median. The same way, if I want to find the mode of a given data, then how we can find mode of given data? So see here, we have three values, three data is given here. First data set is this, second data set is this, and third data set is this one. So in this data, how many times 3 is we will calculate the frequency of each data point. In the case of mode, we are calculating the frequency of each data point, how many times that particular data point appear in the data set. So if I'm saying in this particular data set 3 appeared how many times? 3 times. 5 appeared 2 times, 4 appeared 1 time, and 2 appeared 1 time. So what is the mode of that? The data which is occurring more frequently, that data point will become mode of that particular data set. So what is mode here? So 3 is repeating many number of times compared to other data points. So what is mode for this? 3 is a mode. The same way we will see for another data set. So we have 6, 8, 3, 9, 8, 6. So 6 is occurring 2 times, 8 is occurring 2 times. In the same way 3 and 9 is appearing only once. So in this case, 6 and 8 both are appearing 2 times. So mode for this data set will be 6 and 8 both. Okay. So clear how mean, median and mode we can find out. The same way we have another statistic measure which is called variance and covariance. So what is variance here? Variance is nothing but it is like how of your data set is far from the mean. That is called variance. You have a data point. Now you want to find the distance between the data point and the mean value, square of mean. That is called variance. So when I'm talking about variance, it is expected value of the square variation of a random variable from its mean value in probability and statistics. Informally, we can say that variance estimate how far a set of numbers are spread out from their mean values. Okay, and the value of variance is equal to the square of standard deviation, which is another center 2. To represent the variance, we can use different symbol. We can use sigma square, s square of variance of x. And this is the formula which we are having, right? So x is the value for what we are finding the mean, for what we are finding the distance, and mu is nothing but mu is mean. Fine. So this is a formula for variance. Now we will solve an example here, then it will be more clear to you that how variance we can calculate. So suppose we are having a numbers which is 3, 8, 6, 10, 12, 9, 11, 10, 12 and 7. So this is the value which is given to us. So first of all what we have to do, we have to find the mean. So what is the mean for this? We know mean is nothing but sum of all these value divided by number of values, which is 8.8 here. So this is step number 1 where we are calculating the mean. In step number 2, what we are going to do, we will find the distance of each value from the mean. We have to find, and mean we are representing through mu here and value we are representing through x. So I am preparing one table here. I have written all the values which is given to me. I found the mean value. My mean value was, in this case, my mean value was 8.8. So now I'll subtract the given data point minus mean. So this you will get the values x minus mu. So for every value you will find the x minus mu, and finally you will do the square of that. Square of this, then you will find the square of this is what? 5.8 square is 33.64. In the same way you will find the square of all the values. Fine. And finally you have to do sum of all these square of values. So what is the sum of all the square value, which is 73.6, and total number of value is what? N. So divided by n, so it will become your 7.36. So this is your variance. So variance is 7.36. Clear? How to calculate the variance? First you have to find the mean, then you will subtract each data point from the mean, and finally you will do the square of your distance, and then divided by the number of values, that will become your variance. So variance we will find when we are finding the distance from one value. You have only one variable, then you will find the variance. In the case of, suppose you have two variables, you want to find the distance or a relationship between two variables, then variance will not work here. Here we are using the concept of covariance. So covariance is another static measurement to know the relationship of variance between two variables. So whenever we are having two variables and I want to find the relationship, then we'll use covariance. If we have a single variable, then we'll use variance here. Okay. Now, the covariance indicates how two variables are related, and how also helps to know whether the two variables vary together or change together. So I want to know the relationship between these two, how far they are from each other or how close they are from each other. That if I want to find out, then we'll use the covariance, and covariance we are representing through x of x comma y. X is one variable and y is representing another variable. Right? So covariance, if I want to find out the covariance for population, for the whole population, my formula will be this one. Means I want to find the covariance for the whole data set. So that is called population. So formula will be this. And if I want to find the covariance for a sample data set from the population, then my formula will be a little different. At the place of n, we are using n minus 1. That is the only difference for finding the covariance for population and finding the covariance for sample data set. Clear? Now we'll take a simple example and we'll try to find the covariance for the given question. So what is this? What this question is saying? We have a table which describes the rate of economic growth, which is representing through xi, and the rate of return on the S&P 500, which is representing by yi. So we have two variable x and y. Using the covariance formula, determine whether economic growth and S&P 500 returns have a positive or inverse relationship. So for that we have to compute covariance. And before computing the covariance, what I need to do, I have to find the mean of x, I have to find the mean of y. Then only I can find out the covariance between x and y. Fine. So my x is this is given, y is also given. I have to find the x mean and y mean. Fine. So first we are finding the x mean and then we are finding the y mean. So we know how to find x mean and y mean. Number of sum of total values divided by n. In the same way, sum of total values of y divided by n. So my x mean is 3.1 and my y mean is 11. Now I'll keep all the values in the table and I'll get my results. So xi is given, yi is given. Now I have to find the distance from xi to mean and yi to mean. Fine. So xi minus x bar we are finding, yi minus y bar we are finding. So these are the results which we got. Fine. Now I want to find out the covariance between x and y. So if I want to find the covariance between x and y, what I have to do? I need to do the sum of all the values. So I have to multiply this with this. Minus 1 multiply with minus 3 plus minus 0.6 multiply with 1. Same way 0.9 multiply by 3 plus 0.5 multiply by 1. And we are doing this for a sample data set. Then that's why we are using n minus 1. So n minus total values are 4. N minus 1 will become 3. So my covariance value is 1.533 here. So clear how to find the covariance. So I hope it's clear that how we are finding the covariance. Now, just I'll give a quick summary that what exactly we have learned in today's class. We learned about the statistics formula where we discuss about mean, median, mode, variance and standard variance and covariance. So we have discussed all these points. Standard deviation we have not discussed. We'll discuss in the next class. Okay. Thank you.